one of the things about me is I have a really good long-term memory. I don't really have much of a short-term memory. I don't even remember who all you people are. But I remember when I was in kindergarten, there was a school play that I was in called Go and Buggy. And I was going to be a butterfly in this school play. And one of the biggest disappointments in my whole life was getting dressed up as that butterfly, and someone finally told me I was not going to actually be able to fly around the gym. That was super disappointing. Learning to fly would be so uplifting, don't you think?
Wow.
All of that build just for that. Sorry.
That made up.
No, that was real, actually. That's true. I have pictures. Maybe I'll bring them in sometime. And I'm sorry for that joke. Yes.
Are we going to do an egg drop this semester?
Yes. Yep, that comes later. In other news, did you hear about all of the water animals that escaped the zoo over the weekend? Oh my gosh. It was utter chaos. Oh, that was pretty good. Come on. Oh, dear. Okay. Utter chaos. So, let's take a quick look at the question, and then we'll do the activity for today. We're going to consider a ball that is rolling off a table and a ball that is just dropped from the same height as the table at the same instant that the first one falls off of it. So, which of these two balls is going to hit the ground first? Yes, Caroline.
I think the one that is just dropped at the same height.
Okay.
It's falling straight down, whereas the one that rolls off, it's like still moving horizontally.
Sure, so it's covering more distance overall, perhaps. Other thoughts on this one? So the main thing we got to keep in mind for this is that gravity is going to act the same on both of these objects, whether one is moving horizontally or not. Even if an object is moving horizontally at a very fast speed, gravity is still going to act on it the same way as if the object is just released from rest. Vertically, both of these objects will be accelerating down at 9.8 meters per second squared. So in reality, they're both actually going to hit the ground at the same time. It's kind of crazy to think about, and that's why the question is there. It's a common misconception. But yeah, they'll both hit the ground at the exact same time. And later on in the semester, you'll see the Mythbusters have, this actually isn't the Mythbusters episode we'll be watching in full, but we do watch a portion of the episode where they have a bullet that is launched from a gun horizontally, and they have a bullet that is dropped the instant that the gun fires. And what they find is that both bullets actually hit the ground at the exact same time. So it's the same story. Regardless of what's happening horizontally, both objects are accelerating down at 9.8 meters per second squared. Okay. The only other thing we really need to talk about in this section is things that aren't rolled horizontally or thrown vertically. Perhaps something is kicked at an angle. And this is what we're going to be spending time talking about today. So you're going to want to draw this. I know it's intimidating, but don't be intimidated. That's why I'm here. As you draw that, I'll pass out the next round of homework. This won't be due until Thursday, and you'll have class time to work on it tomorrow. Feels like to. What's more, let me know. You don't need to write down the stuff on the board here. That's not yet anyway. If you want to write down the first one, you can. So, in this problem, it looks complicated. You got a person that's on top of this cliff thing, and he's kicking a ball at a 60-degree angle at 30 meters per second. And in general, if this is what your setup is, it's going to ask for how far away from the cliff that object is going to land on the ground. And that's what we're going to solve for today. Now, there's actually a 3-step short way to do this, and there is a 6-step long way to do it. So I'm going to show you the long way, and then I'll show you the short way. And yeah, we'll do that. The reason that I want you to do the 6-step long way first is because it'll really help practice some of these equations. We really want to make sure that you're comfortable as you can be with using those equations in different scenarios. So, in order to solve this using 6 long steps, first step is we have to take that velocity that is right here, and we have to break it up into its x and y components. The reason we got to do that is because all these equations are either vertical or horizontal. Is this vertical or horizontal?
Vertical.
Vertical, excellent. This one?
Horizontal.
Nope.
Vertical.
This one's vertical. How about this one?
Vertical.
How about this one?
Horizontal.
Very good. And you can tell the vertical ones because they have an acceleration. Vertically, you'll be accelerating down because of gravity. This one doesn't have an acceleration, so it's your horizontal one. The first step is to break up your velocity into the x and y components. So if you want to write down step 1, you can do that. And we'll just go through that together. So that velocity is both horizontal and vertical. It's partially going to the right, it's partially going up. So the same thing that we did with force, we got to make a cute little triangle, and we got to figure out how much of this velocity is actually going straight up, and how much of it is going straight across. So we got to use sine and cosine to do that. In order to solve for the adjacent side of this 60-degree angle, cosine, absolutely. So the cosine of our angle is equal to adjacent over hypotenuse. Therefore, the original velocity in the x direction is equal to 30 times the cosine of 60 degrees. And if you do that properly and your calculator is in degree mode, you're going to end up with 15 meters per second. That would be your original horizontal velocity. Is this horizontal velocity going to change at all? Why? Well, if it's 15, how come, the vertical velocity is changing. How come this one's going to stay the same?
It's not going to hit into something that's going to obscure it.
Yeah. There's... As long as there are no horizontal forces, this object isn't going to change its horizontal speed. So 15 meters per second is what it will be traveling at horizontally until it hits the ground. Vertically, to solve for the opposite side, that's going to be sine. And if calculated properly, that's 26 meters per second. And that's the first step.
That's only step 1.
That's only step 1. But regardless of whether you do this the long way or the short way, anytime you're given a question where an object is thrown or kicked or launched at an angle, this is always step 1. You've got to figure out what the original velocity is, both in the x and y directions. Otherwise, your numbers aren't going to be able to fit into these equations. You're never going to see 30 meters per second anywhere in any of these equations because these are vertical and horizontal equations. And this is neither completely vertical or completely horizontal. That's why we got to find those two. Everybody on board so far? All right. So the next one, the time to reach the maximum height. We've got 4 equations here. Any thoughts on which one we should use to figure out the time it's going to take for this object? Let's move it over here for the folks in our television audience. How long it's going to take for the ball to reach its peak height right here. This one right here? Okay, we could, let's see here. So, the last one? Yeah, we are looking for time, so that's kind of an important thing. Let's just see here. So yeah, this one probably won't work. This one, we know the, well, I guess we don't know the final height, do we? Because we don't know how high up it's going to go. So this, we don't know. We know what this is. That's 15. Original velocity in the y direction, that would be the 26 that we calculated. So we know everything else, but we've got 2 unknowns, that height and that time. So I'm actually thinking of trying out this one right here. So let's just see where that equation takes us. And you know what? If you don't pick this equation first and you try some of the others, that's okay. It won't work quite well. And then you move on to a different equation. And hopefully you'd eventually land here. So what's the final velocity going to be when it reaches its maximum height? 0, because this is a vertical equation. And vertically, when this object reaches that point, it's not moving vertically anymore. So your final velocity there is nothing. That's probably the hardest part to figure out if you're using this equation. Original velocity, is that going to be 30? Nope.
Negative 30?
Nope.
30.
Nope.
Wait,
Oh, would it
negative 26.
Nope.
horizontal or vertical? It would be 26
26. Why?
because it's a vertical equation, not the velocity in the y direction.
Exactly, yeah. This is a vertical equation because it has that acceleration there. So vertically, my original velocity is that value that we calculated in part number 1, which was 26. Again, you'll never see 30 anywhere in these equations because 30 is a horizontal and vertical thing combined. And these are all just vertical or horizontal. Acceleration, of course, is negative 9.8, and time is the only variable, so you can solve for time. When you do, you're going to get 2.65. That is how long it takes for this object to reach its maximum height there. Questions so far? Everybody still on the ball? Cool. So the next step, find the maximum height. How high is it going to be? Can I use this equation to find maximum height? No. I'm not. How about this one? No. This one, we're not going to because it's an x equation. It's horizontal. This one, because there's no height in it. These 2 equations are kind of interesting for this because if I'm looking, this equation I think would work because we know the final vertical velocity when it reaches that height is going to be 0. The original velocity is going to be 26 squared, yep. And then acceleration, negative 9.8. We could use this to solve for that change in height y. The only thing is, we're looking for maximum height, so whatever value we get for this, we'd have to add the 15 original meters that were off the ground. So that one would work. In addition, this one should work just fine too. I'm going to use this one because it directly takes the original height into account. I don't have to think about it later on. So my final height is what I'm looking for. Original height is 15. What's my original velocity? Yes, 26, because this is a vertical equation. That's my original vertical velocity. And what's my time going to be? Yeah, 2.65, just what we calculated before, because that's how long it takes to go from here to the maximum height. 2.65, 1/2, negative 9.8, and then, yeah, 2.65 squared. Ran out of room. Okay. So if you do all this on your calculator, you'll get yourself a value, and that height will be 49.5 meters. So that is the maximum height that this has over the ground, which is way down there. And hopefully it's the same thing we'd get if we did this equation. Well, I know it would be the same thing, because physics works. All right. Time of descent. Any thoughts on which? Well, let's go through them again. Should I use this to find time of descent? No, because it's a horizontal equation. How about this one? Well, I heard a maybe. Okay, we'll keep that in the back of our minds. How about this one? Probably not, because if I wanted to find the time of descent, I would need the original velocity, which I would know, but I don't know the final velocity. So that one would have two unknowns. And of course, this doesn't have time in it at all. So yeah, we should go to the y equation again. And just in general, if you're kind of curious, what would be a good place to start? Oftentimes, if I had to just randomly pick an equation and hope it worked for me, this would be the one I would pick. So, time of descent. What's the final height going to be? Yep. What's the original height going to be? 49.5. Yeah. Because that was its maximum height. Now, what's the original velocity going to be here? Good guess. 0. Why do you think it's 0, Ella? Oh, it was a good guess, though, anyway. Because for this equation, we're considering what's happening from the maximum height all the way down to the ground. And when you're at your maximum height, the vertical velocity is 0. So this whole thing is nothing. And then we've got 1/2 at squared. And you can solve this equation for time with a little bit of math. So if I shift this over here, 4.9. So then once you get to this point, you got a square, so you get rid of the square by taking the square root. And I think you should end up with 3.18 seconds. How are we doing so far? Again, I would not expect you to do this on your own right now. The whole purpose of this is just practicing so that, the more times you use these equations, the better off you're going to be and the quicker you'll pick it up. So we know it takes 3.18 seconds to go from the maximum height to the ground. We know it took 2.65 to go from there to the maximum height. So how do you suppose we find the total air time? Just add them up. So 2.65 plus 3.18 is going to get you 5.83. So the total air time is 5.83 seconds. And then we can use that total air time to figure out the horizontal range. So there's one horizontal equation here. It's this top one. So distance is equal to velocity times time. What velocity am I going to put here? 15, yeah. Because this is a horizontal equation, so we got to put a horizontal velocity in it. Time, of course, 5.83. And out pops your total horizontal distance of 87.5 meters. Whew. Well, that was something, huh? But the cool part, at least, is we don't got to go anywhere else than these four equations. It doesn't get any more complicated than what you're seeing right here. This is the toughest problem you will see in this chapter. And there's not one on the test like this. There's only 2 challenge problems on the piece of homework that are kind of like it. But so, yeah. So, that is the tough way to do it, the long way to do it. Another reason that we might want to do it this way is maybe the question does ask for the maximum height. Maybe it does ask for how long it takes for it to reach its maximum height. It's good to be able to do that. Let me show you the short way. We've got more than enough time to do this. How would you like to take this whole thing and make these 4 steps into one? That'd be nice, huh? Okay. You're going to have to visit an old friend, though, in order to do this. Let me explain. So, you still got to do the x and y components. You can't get away from that. If you've got angled motion, you got to figure out what the velocity components are horizontally and vertically. But if you want to figure out your total air time, you can do that with one equation. Which one was the one I said that probably a good idea to go there if you're not sure where else to go? The second one, yeah. Let's just see what happens. Whoops. T to the 0. So let's look at this picture like overall now. What is the final height after this is all completed? 0. Some of you probably know where this is heading right now. What is the original height? 15. What is the original velocity? Good guess. This is still a vertical equation, so it's still 26. Yep. One half times negative 9.8 is negative 4.9. And what do we have before us? Yeah. So negative 4.9 would be your A, 26 would be your B, 15 would be your C, and then you go ahead and plug it in. Out would pop your time. And then you just use that to figure out your horizontal range. Yeah. So if you're not afraid of the quadratic, you'll be in good hands. Questions on any of this? Okay.